All right. A Kubernetes cluster is comprised of a master and several nodes. The node is where the pods run. So let's say you have 3 different nodes and you create 3 pods. It could be the case that the pods will run on different nodes. Now, if the Kubernetes cluster reaches a certain size, well, let's say you have 10 nodes and each node has 32 GB of memory, well, there are a lot of pods you can start. And the question is, how do you divide the Kubernetes cluster? For example, if you deploy application systems that are entirely independent from each other. So let's say you are part of an organization, or you have 500 employees, 50 or 100 of them are developers, and they develop different products. So the question is, do you create multiple Kubernetes clusters, or do you split up the Kubernetes cluster into different namespaces? In other application development platforms, such as Cloud Foundry, there is a concept of organizations in Cloud Foundry and spaces. So you have 2 levels of tenant separation. The first would be the organization, which is basically the tenant. But within a tenant, you could, for example, have a testing, a staging, and a production space. In Kubernetes, there's a cluster, which is basically the deployment of your Kubernetes cluster. And there are namespaces. So in contrast to Cloud Foundry, the tenant isolation within a cluster is not as high as it is with Cloud Foundry. Therefore, it is to be expected that you will have, in a large organization, that you will have more than one Kubernetes cluster, where in Cloud Foundry, one Cloud Foundry environment would be good enough. However, if, for example, you look into the example of having a staging and a testing environment, you could isolate the 2 in different namespaces. But namespaces are more important than that. Sometimes, for example, you want to set up a subsystem in Kubernetes. For example, data service automation, or a service mesh, which would be an add-on providing you additional functionality. Also in this case, you would like to separate the deployment of all the resources making up that subsystem into a separate namespace. So the namespace concept allows you to some degree isolate workloads from another. I wouldn't expect too much from that isolation, but it's good enough to, for example, if you set a namespace to restrict all the actions you apply against the cluster to a particular namespace. So if we'd be sharing, for example, one larger Kubernetes cluster with several groups performing this training, we could use namespaces so that each group only sees the resources they have created. And because that could be the case in future sessions, we will introduce namespaces with respect of creating tenants for isolating the perspective each group has on the cluster. So be aware, still there could be interference between the groups. For example, if you do not allocate a namespace, per default, you do not allocate a namespace resources. So one group could consume the cluster resources so that the workloads of another group do not have appropriate capacity available so that their workloads can be scheduled. There's if you interact with the kubectl using kubectl with the Kubernetes cluster, and you issue a command, for example, retrieving existing pods, you'll get the reply, there are no resources found in default namespaces, which means we are in the default namespace. So there is a namespace called default, and if you do not specify namespace, this is where all the operations you perform will be performed in this particular namespace. You can also retrieve a list of existing namespaces. So the default namespace here I mentioned already, but there are also some other namespaces. Particular here, for example, Kudo is a workload that I've been deploying for another tutorial I'm creating at the moment. So it's not something that you'll find in a fresh Kubernetes install. So let's create a namespace for our training here. It's called Kubernetes training. Often Kubernetes is abbreviated as K8S. And you can see here's our namespace. Now, if you use Kubernetes for a while and you use kubectl for a while, you will see that there's a certain systematic naming of operations. So you'll often have kubectl, and you'll use the verb get. So if you just use the word get, you will see that. And you can see that there are a few examples on how get can be used. The way get works is that you'll say kubectl get, and then usually you say, well, that's the resource I want to get. So in this particular case, you could say kubectl get namespaces, and you get namespace. Or you could say kubectl get pods, and you get pods. So here, the kubectl API resources, for example, gives you a list of resources the Kubernetes cluster knows. Some of them have been they have been introduced to the Kubernetes cluster by add-ons, and they are not native Kubernetes resources. For example, instances here is part of the Kudo subsystem, as you can see here. Ingress, for example, is an add-on, but for example, jobs and cron jobs are part of the Kubernetes system. So daemon sets, controller revision, replica set, they are all Kubernetes resources. So consequently, we could say kubectl get roles or kubectl get deployments. You will see throughout the training that once you understood the way these commands work, you can also conclude to how would the command be used for other resources. It's basically always the same. All right, so now we have our Kubernetes namespace. It is worth mentioning that you can interact with Kubernetes using the command line in multiple ways. So what we've done now is we've told Kubernetes to create a namespace, but you could have also described the namespace in a YAML file and then apply the YAML file, and you'd have the same result. So let's go back. And we delete the namespace. Deleting a namespace also deletes most of the dependent objects. So you'd be, this could take a while. In this case, the space was empty, and it has been deleted rather quickly. All right, so I create a file. You can, name is arbitrary. And we'll specify the API version. This is what I meant earlier. Sometimes these resources, their API versions change over time. So if you're using an older version of Kubernetes, that could be a different line of text, although the general structure would be similar. All right, so we're describing namespace. All we say is just create a namespace called Kubernetes training. So we are referring to an API version here, which is how you describe an object in Kubernetes. So there could be different API versions for different kinds. So in this case, the kind of object we want to create is a namespace. And in the metadata of this object, we define its name, which is Kubernetes training. In order to execute the declaration of the namespace, that's basically what it is. We're declaring a namespace or describing a namespace, and now we would like to apply this declaration to the Kubernetes cluster. So the command to do that is kubectl apply. We would like to apply the contents of a file, which is the namespace YAML file we've created earlier. For those of you who haven't seen YAML files before, it's basically a very simple markup language that describes data structure. So you can basically have hashes, arrays, scalar variables, and so on. And it uses spaces to declare the structure of the data structure. There's plenty of resources describing the YAML format. So if you're not familiar with that, maybe looking at it a few minutes, looking up a tutorial or a Wikipedia page should be good enough. All right, so we've done that. Kubectl get namespaces, and there you go. The result is basically the same. There are several advantages over using files, because if your deployments get more complex, you want to own the commands that will be used to provision your application. Think of a continuous integration, continuous delivery pipeline, where whenever you create a new version of your code, it will be automatically tested and also automatically deployed to a test system that could be a Kubernetes cluster, where, let's say, a test suite is run in production, or where you perform manual testing. So in order to make that deployment repeatable, and in order to automate that, you'll also want to describe these resources explicitly, and also check this into version control. It's basically part of your code base. If you look at the application system as a whole.